Welcome, everyone. My name is Shannon Valdezon. I'm on Esri's Health and Human Services team. We're happy to be here today to talk to you about the benefits of real-time GIS and analytics for the health industry. We have Matthew Thomas as our speaker today. He's a solutions engineer on the Health and Human Services team, and he'll be exploring how health professionals can use real-time GIS to improve situational awareness and optimize operations. I did want to go over a few logistics before we start. Please note on the right-hand side of your screen, you should have the GoToWebinar toolbar. There you will find a section for questions. Please type in any questions you have for Matt throughout the presentation. I will be monitoring this, and at the end, we'll make sure to save some time to answer them. As a reminder, this will be recorded, and the recording will be made available in about a week. Thank you for joining us again. Matt, over to you.
All right, thank you, Shannon. I appreciate it. All right, we'll just dive right in. So where we're at on our meetup series for this year, this is number 4, and we have one more this year coming up in November. At the end of my presentation, I will have a resources slide as well as an events slide, and both of those will contain links. There's a PDF available for download for you of all of my slides, so I recommend downloading that PDF as my resources and event slides at the end. Those are all just hyperlinks. So if you just download the PDF, you'll have access to all of those. And so my event slide will have some links available for you for recordings of past meetups as well as registration for future ones. So today, what I've got planned for us, we'll do kind of an overview of real-time GIS just as a concept and what kind of tools are available within the Esri platform, as well as we'll take a tour of Geo Event Server specifically. And then I've got a couple of demos, one about social media feeds and one about identifying asset risk within a weather event. So just a couple of scenarios where we can use the Geo Event Server and real-time GIS. So diving right into just an overview of real-time GIS. Real-time data is just like it sounds. It's data that is changing in real time. So whether it's things that are moving, any type of asset, vehicles, people, animals, anything that migrates, we want to have an understanding of where they are at the current moment, as well as stationary items that have recordings. So from the health aspect, the water we drink, the air that we breathe, those can all be monitored by stationary sensors and give us an idea of what hazards may be coming down the line for our populations, as well as just isolated incidents as they happen, any type of disaster, emergency that affect how we live our lives. So some of the tools that Esri provides within ArcGIS for giving us real-time data. One of those is the Living Atlas of the world. The Living Atlas is great. I definitely recommend it to pretty much everyone I talk to. And it includes a lot of applications like this hurricane application or this wildfire application, as well as a lot of different data sets like the other two listed here, earthquakes and weather, that these are maintained by the provider. You can just access them and use them, plug them into your own maps, your own applications. Within the Living Atlas, whether you go to the web interface itself or just in the arcgis.com map viewer, you can filter down to specific things. Earth observations is a really good tool here, or a good classification. So all of my items listed here, these are part of the Earth observations just by going to this filter button and then narrowing it down to the items of interest. And I do recommend, this is in my resources page at the end, but Public Safety did a webinar this summer on real-time situational awareness, and a lot of what they covered is the data and content that are available within the Living Atlas, and they really break down a lot of that, and a lot of that is very relevant in terms of public health preparedness, hospital preparedness, things like that. The field apps that we have, these are great for real-time situational awareness. Of course, we use desktop and ArcGIS Pro for planning field operations. Workforce is a great tool for interactive communication and real-time data sharing between the dispatcher and the folks out in the field. Once the folks use Navigator to get to where they're going, then there's a great collection of of tools available for capturing data. Collector and Survey 123 for the field collectors, drone to map obviously for remote sensing, and then Tracker for capturing your field workers' locations along the way. And Quick Capture is the new one for capturing data in a really simple, easy to use tool. And Operations Dashboard, which I'll cover a little bit more in a minute, for viewing the entire thing, all of these different incoming layers in context. There's some great crowdsourcing applications. This one is the Lost Loved Ones, created by an Esri employee, and it's a tool for anyone who's lost someone special to them due to the opioid epidemic, to create a tribute, a memorial to their loved one here. This has really helped to destigmatize the opioid crisis and help us put faces on the statistics that we see to really make it more personal. And the National Safety Council has adopted this application and has it hosted on their website. So all of this data is coming in real time, and we can see it as it's being populated. The Geo Event Server, of course, which is where we'll spend the bulk of our time today. Geo Event Server, it gives you the ability to simultaneously tap into, analyze, and display real-time data from pretty much any type of sensor that you have. So whether it's syndromic surveillance data, or if you're monitoring NEMSIS data from an EMS system, or if you're working in public health preparedness, hospital preparedness, the weather feeds, which that'll be the demo I show later on, that's a good usage of this application. Electronic verification of visits, understanding where people are and where they should be. All of that can be tracked and processed through the Geo Event Server. Let's see. And I do want to put in a couple plugs in some of the resources. If there's a Geo Event Server Gallery group within ArcGIS Online, and if you just Google that, it'll come right up, and I have it in my resources page at the end. It has a lot of the inputs and output connectors that will allow you to gather data and send data to places that might be a little bit harder to reach. As you can see, there's some social media feeds. Those are familiar to folks. There's a lot available. There's also a very active community of people creating unique connectors, inputs and outputs that can be shared. And within this gallery, one I'd like to highlight is the tutorial, the introduction to Geo Event Server. When I first started learning GeoEvent, this is where I started, and it's got about 6 or 7 modules, and it's very comprehensive. It runs through the entire scope of what the application does and what it can do, and gives you a little bit of taste of everything, so you can really become a master of this piece of technology. One that's coming up later this year, at the end of this year, is I believe that's when it's slated for, is ArcGIS Analytics for IoT. So where GeoEvent is part of the ArcGIS Enterprise suite, Analytics for IoT will be baked into ArcGIS Online, and it's kind of a combination of the capabilities of both GeoEvent and GeoAnalytics, where GeoEvent is for real time, GeoAnalytics is for big data, and Analytics for IoT is built for both. So it's into ArcGIS Online, so you don't have to implement or maintain the technology, which really simplifies the process for you, the user, as well as your IT, your IT folks. But we do want to keep in mind in the health industry that ArcGIS Online is not built for PHI. So as we're processing PHI data, we would need to do that on premises versions using GeoEvent and GeoAnalytics. But this is a really great tool that we're really excited to come out. And then of course, Operations Dashboard. As we're working with real-time data, this is a great way to put it all into context. And this is often used by folks higher up within the organization, folks at the executive level, higher level stakeholders. They can use these to make decisions at a glance, to look at it and get a good situational awareness of how things are going within an organization. In this example, we're looking at surveys being collected as part of a rapid health needs assessment, where women were interviewed about women's health, as well as this one might show. This one shows it shows clinic usage at the current moment, and we can see what the wait times are and how appointments are being met within individual hospitals throughout South Carolina. This one is from the city of Tempe, the opioid use probable, where we get a good look at the opioid situation within the city of Tempe, Arizona. Now we'll go into our tour of GeoEvent Server. So in general, GeoEvent Server, it's part of ArcGIS Enterprise. It is an optional piece, of course. ArcGIS Enterprise on its own, the base deployment it'll include a portal, which is your interface for interacting and storing content and managing users and licenses and all of that. And it also has a GIS server, which is the engine that supplies the data into the portal, so that you can view the maps and interact with them and make use of them and maps and analytics. So GeoEvent Server is an additional server that can be also plugged into the portal for ingesting data, analyzing it, storing it in different places. Here you have Spatialtemporal Big Data Store. It can also store in some of the more standard locations, your relational database management system like SQL Server, Oracle, as well as the ArcGIS data store, which is part of the base deployment, which is for your hosted feature services. We can visualize the data through different methods, whether it's through feature services or stream services, or and all of that data can be recorded and used and aggregated and used in a more traditional sense, brought into the desktop environment, used in a lot of different ways. And data can also be pushed out to other audiences and other types of systems. So I just want to go through a few of the concepts that are critical to understand to use GeoEvent. It always starts with an input. Data has to come from somewhere, and there is a good selection of out-of-the-box inputs. You can see this list here. We can pull from RSS feeds. It can pull from existing services within ArcGIS Server, different portals. It can monitor as other layers of data are changing. GeoEvent can pick up on that and make use of that. Data can be pushed in or it can be pulled in. So GeoEvent Server can do the polling from some external website to pick up any type of data, JSON, XML, whatever the format it is, and pull it in. Or data can be pushed in, treated as a server. So it can act as a server or a client. It can also watch a file locally within the server to pick up on any data changes. There's the Esri Gallery, which I pointed out earlier, where there are a number of input connectors that are not out of the box, but they can just be brought in and deployed very simply. And then there's also a partner gallery. A lot of our partners do create custom input connectors. You can create your own. There's an SDK available for you to build your own input connectors. And just like the input connectors, we also need output connectors. So the data needs to go somewhere. Once it is ingested by the system, after it's processed and analyzed and we do what we need to with it, it has to be pushed out to another location. And sometimes that first one on the list, add or update a feature. Sometimes it's just about having a feature service be updated. And that might be a feature that's stored in our on-premise system. Might be stored in an Oracle database, for example, and that those data are just being continuously modified by the GeoEvent activities. The data can be pushed into different formats, GeoJSON, JSON. It can send text messages or emails, instant messages. So as certain criteria are met, maybe someone in your organization is driving somewhere they should not be, that could be picked up and a text message could be sent out to someone who is responsible. There's a note about the Spatialtemporal Big Data Store. I will give you a little more specifics about that in just a minute. And then just like the inputs, you can build your own outputs, and the gallery also has a number of outputs available that you can see here. So data can be sent to pretty much anywhere from the GeoEvent server. So one of the concepts, so let me pull open the GeoEvent Manager interface. When you first launch it, we look at our monitor of all inputs that we have set up, all outputs, and all services. And here we can manage them individually. Let's see. Also come over here to where our definitions are. Let's see, I let it sitting for just a little bit too long. Sometimes it will prompt for a password. It's kind of like when Netflix asks you if you're still watching. So I was kind of expecting it to do that at some point. Let's see, I believe I have it pulled up here as well. Okay, we'll give it a minute to reload. But so the Geo Event Definition, this is an important concept to understand with GeoEvent, in that any data that's coming in or going out needs to have a schema that GeoEvent recognizes, a data schema. So just as an example of how that might work. So say my GeoEvent definition is set up like a table with the following fields: city, county, population, XY. We might expect data about a city to come through the system. So if a piece of data comes through that is set up like this, we can clearly see that this does not fit that definition. Those attributes will not fit into that table. So the system will ignore it. But if a piece of data comes in like this, this seems to be much more appropriate. That will plug in very nicely into the system. It will be accepted and the data will be received. So that's the concept of a GeoEvent definition. Another concept that is important to be aware of is geofences. And a geofence it's essentially some reference data. So geographical reference locations, they allow us to compare our ingested data against this reference data. So in these examples here, those blue hash boundaries might be considered a geofence, and then a vehicle or a person migrating through them would be the tracks. So say we have a home health provider, and this is an area where they're going to be working throughout the day. We can track when that person is to enter this area, and GeoEvent will allow you to interact with your ingested data versus the geofences using any of these operators. So a person comes inside the geofence, they enter the geofence, they're outside the geofence, they exit the geofence. So yeah, it turns into a Dr. Seuss story pretty quickly, but any relationship between your ingested data and the geofence can be analyzed and noted. So if data is intersecting, or if it's contained by it, or if it crosses through it, or if it's disjointed from it, and some of these, in some cases, they'll have the same meaning, but they can get pretty specific to where specific ones are used. I generally would recommend intersect. If that's ever seemingly appropriate, intersect is usually the best one to use, just from experience. I want to make a shout out to our new mobile application Tracker for ArcGIS. Tracker is part of ArcGIS Enterprise, where the user just has the mobile app. It's really simple for the user. They open the application and they hit track, and then the application is just running. It's very it's not too hard on the battery of the mobile device, which is one of the real perks of Tracker. But every so often it just records a point. All of the data are stored as points, and they're stored within ArcGIS Enterprise as point data. They're visualized within the Track Viewer application, which comes with Tracker. They're visualized as lines just for our sanity when we're viewing it. But the data are stored as points, which makes it really convenient to work with GeoEvent. So say this is my colleague Jonathan, and this is his activities this month around the Redlands area. So let's say that he is a mobile provider. Maybe he conducts inspections of restaurants, and he needs to be working in this designated area that I have as my geofence here. GeoEvent Server can track when he enters the geofence as well as when he leaves it. So the amount of time that he spends in his assigned area will be completely captured. by the system, and then that can be just pushed out to reports, and that can all just be very much automated by the system. I wanted to mention the Spatialtemporal Big Data Store. None of my demos will touch on that today, but basically this is for working with big data and for storing big data. Spatialtemporal Big Data Store, there's no extra license you need for it. As long as you have ArcGIS Enterprise, you can install this as well. It's part of the ArcGIS Data Store. When you install it, it asks you which type do you want. Do you want a relational database, which is the most common, kind of the starting point, or do you want a Spatialtemporal Big Data Store or a tile cache? So with Spatialtemporal Big Data Store, GeoEvent can write to services to be stored there. It's for big data. As you have a lot of data coming in and you need room and processing capability to store and manage it all, you can just have the results published to there. And it's really slick how it works. Anytime you write from GeoEvent to it, it'll store in two separate services. There's a hosted feature service and then a hosted map service. And the hosted feature service draws points just like we're used to. And those can add up really quick to where they don't make a lot of sense. If there's too many points, it's hard to really make quick understanding of them. So the hosted map service, it does this on-the-fly aggregation where you don't have to do anything special. These boxes will just show up on your map when you drop them in. And as you zoom in and zoom out, the boxes will resize, and each number shows us how many points are inside of that boundary. So we get a really quick understanding of where our data are as they're coming in from Geo Event Server. So for the first demo I want to show, actually I want to save time for the second demo to walk through the entire process. So this one will be a little bit more conceptual, but it's about capturing social media feeds. So my goal is that I want to capture public opinion via Twitter. So I might have a number of reasons for doing this. I might want to just get an idea of the public perspective during an epidemic, or I might want to gather public opinion during some sort of crisis or a disaster or some sort of event, or maybe I just want to monitor my customer satisfaction for my clinic, my hospital, my urgent care, my emergency room, just see what kind of things people might be saying. So the Twitter input connector, it is part of the Geo Event Gallery. So when you peruse that gallery, it's there for download, no extra cost for it, and you just install it right into your GeoEvent, into your GeoEvent system. And part of that is that you'll have this tweet status GeoEvent definition. Remember the definition, this is where all of the fields for the expected data will be identified and listed out. So looking at that tweet status definition up close, this is what it looks like. So the fields are all listed there. We see the types of data that each field is, and then we can assign tags. These tags are just defined by the system. The time start will generally go on the first date field in the data set. Geometry will be assigned to whatever the geometry field is. The field name can be anything. It's usually called geometry. In this case, it's coordinates. The track ID, this is an important one. This is your unique identifier. So in the case of tweets, every tweet will have a field called ID, str, ID string, I assume. And it will have a unique string of numbers that identify that tweet specifically. So every tweet is unique. It has its own ID string value. And so that is what I would assign my track ID. If I'm working with a feature service or something that comes from my ArcGIS online, my ArcGIS system, often there's always going to be a field called object ID. And if you're a user of ArcMap or ArcGIS Pro, you're familiar with an object ID, that it's a unique number for every single row, every single feature on your map or in your data. In GeoEvent, you never want to use the object ID as your unique identifier. You want to use something more logical. So if I have a fleet of vehicles, or if I have unique people that I'm monitoring, each asset should have its own number that is specific to it. We shouldn't rely on the object ID. So GeoEvent, you'll see object IDs come around and you can always ignore them because GeoEvent doesn't really respect them as unique identifiers. You need to have one that fits your data more logically. So when I set up my input connector, which again comes with the download, it's going to ask me for some information up front, and the directions walk me through how to do this. I go to the Twitter developer API, and it has me set up an application, and I get all of this identifying information that's associated with my Twitter developer account. And I'm just using the free one, so it will only capture a small subset of the tweets that are out there. In real life for production scenarios, it's probably better to purchase a license and make sure that you're a developer of the right status to really consume the data that you need. But while I'm setting up my input connector, I'll put the different keywords that I want to track. In this case, I just put a few diseases: flu, measles, and malaria. And as soon as I hit start on my input connector, it will start consuming data that contain those buzzwords. Let's see. So I want to show, actually, I have a couple things first. When the data are coming in, I can have it write directly to just a JSON file. And when I do that, this is an example of the data as it comes in. All of these fields they're exactly in accordance with my Geo Event definition. In this particular one, the text, this is what the person actually tweeted. You can see they talked about flu, and that is what allowed GeoEvent to pick it up. Notice it says geolocated equals true, and then because that's true, it has the coordinates of where that tweet was sent from. So a lot of times the tweets will be false. So if it's geolocated false, then let's see, there's no coordinates, they're just null. So the system will still pick it up, but within my GeoEvent service, I can distinguish whether I want to only filter by the ones that are true, that have a location, or those that are not. So I just want to show you a quick result. So in addition to writing to a JSON output, I can write to a feature service output. So I made a feature class called new tweets, and I just picked several fields that I wanted to capture. I don't need to capture everything that comes in that definition. I can supply my own definition and then have the data reduced to what I want. But after doing that, I ran this for about 30 hours or so, and this is what I collected. And again, you can take that and publish it as a map service, and make it look really nice for a web audience. Let's see, a little lagging, but I just added the firefly symbology here, and seem to have a lag here on my service, but I think you get the idea. But I extracted the data and just stored it as a point layer in a file geodatabase, and then I can go and I can classify it just by the keywords that were tweeted, and then I can go through and filter and separate if I want to look at all my tweets for those 30 hours based on cancer or Ebola, mosquito-borne disease, diabetes, flu, HIV, and AIDS. So yeah, so I at that point it's just data that I can do what I like with. And let's see, 1 second while I pull up my next item. Okay, so my next topic is that I'm wanting to monitor a weather event. So what my goal is, I have a group of assets or some types of infrastructure that are important to my organization, and I want to identify that critical infrastructure that's within the path of a coming storm. Now we have a partner called AccuView or AccuWeather. I'm sorry. AccuWeather supplies data like this, like those storm boundaries, storm expectation boundaries, where this area would be within 15 minutes of a coming storm. This is within 30 minutes, and this is within 45 minutes. So they supply that data, and when you subscribe to them, the data just comes in as a map service. So you can just add it right to your map and visualize it. But in order to do the real-time analytics, we would need to use Geo Event Server to pull that data in and then see how it intersects with our critical infrastructure data. So that'll be my result. Let me pull open my Geo Event Server, and let's see, it's not loading there. Let me pull it open in, I have a remote session here, and I'll just pull it open in here real quick. Put in my credentials. There we go. So I have Geo Event Server, and quick view at the interface. Here is my Geo Event definitions. If I go to my Geo Event services, I have my inputs, I have my outputs. And then here's my list of Geo Event definitions. Any Geofences I don't have any yet. I also have my data stores, any portals that I need to connect to, any GIS servers, ArcGIS Online, I can connect all through there. Any folders I need to connect to just within my own machine, I can do that within here. So let's start with my, I'm gonna start with ArcGIS Pro. So here's my critical infrastructure data. Within Virginia and West Virginia, I have over 5,000 points that I'm concerned about. There's a coming storm, and I want to be aware of which of these are in harm's way. So I have that. I also have a threat cones layer that is completely empty at this point. This will be my storm data, my storm outlines. I will have orange outlines when I'm done. Right now, there's no data. And then I have my threatened assets, which is also empty. These will be my critical infrastructure that are within the path of the storm. So I want those points to turn red when they are when they're in the storm's path. So I have each of these published as a feature service to ArcGIS Server, and I will go ahead and pull this up. So I made just a quick web map, including all three of these layers, and of course, the first one is empty. The first two are empty. And then I also made a dashboard showing the three as well, so I can monitor as the data change in real time. So now we'll take a look at GeoEvent and get started. I want to start with my GeoEvent definitions. So anytime I'm going to be writing to a feature service, then I can trust that the system can write the definition better than I can manually, so I'll always import. And so I would pick the feature service that I want to write to. So I have my threat cones, my critical infrastructure, and my threatened assets. So if I choose my critical infrastructure, these are all of those points all over the map. I need to pick a unique identifier, not the object ID, but one that's actually relevant to the data, which is CID. Each point has a CID value that's unique. I would choose that. And when I do that, I already have it loaded, but it made this CI reference features. I can see my definition, how it is, and it has the track ID listed as a CID. So I have that concept all worked out and ready. I have all three of those definitions loaded. I also have I made one definition manually. That's storm cell predictions. And this is my data, my input data. I mentioned that AccuWeather will provide a map service that I can consume. I don't want to use it just yet though. I want to use sample data of my own. So I made this definition based on my input sample data, which is here, which is a lot to look at. I'm looking at a CSV. I can also look at it in Excel. This particular data, it's not comma separated, it's semicolon separated. So it's a little bit jumbled together the way we look at it. And then because I'm using polygon geometry, it's a little bit harder for me to read and understand in Excel. So I'm just going to look at it in Notepad for now. But each record, I have the site ID from where the storm is being assessed from. I have a storm cell ID, which is unique to that storm. I have the direction it's going, the speed it's going. I have the status, potentially severe storm. The minutes out, they're broken down to 15, 30, and 45, like in the diagram. We have the range, which is 89, and the corrected is 1. And then I have the geometry. So all of these vertices act together to draw out the polygon of the storm cell, or the anticipated storm cell. Now, I like using data like this while I'm developing and testing. I only have 30 records. There's 31. The first one, though, is the field names. With only 30, this is very representative of my actual data. So while I'm developing, I want my data to be small, and I want it to be predictable, and I want to be in control of it. So I can make sure that I'm testing in something accurate, but I also want to be in control of how the testing process goes. Otherwise, I'm at the mercy of the storm predictions, and maybe there's nothing in the data that day, or maybe it's going so fast that I can't really keep up with it to really test my logic. So by having something like this, I have a small controlled input sample. I have this, I'll come back to that. I'm going to go to my GeoEvent services inputs. So I have an input called storm cell predictions, and this received text from a TCP socket. This is a great tool to use, a great input to use while I'm testing with the CSV. I specified that I'm going to be using a semicolon as my attribute separator. Usually it's a comma. And then I use Geo Event Simulator to feed my input. And so I have my input is specified to receive over port 5565. I have that set here, and I hit connect. And then I come in here, and I have that CSV stored on this machine. So I'll go ahead and grab that. And I want to specify a semicolon separating my fields instead of a comma. So this looks a lot more digestible now. And I want to skip the first line because the first line is just my field names. And then it will always look for a time field. It's usually best to have one. I don't happen to have one in this case, and that's fine. So I'm just going to pick field 9, which doesn't have any data in it. So it's not looking for time that's not there. And that's just out of preference. And then I hit load. So with my simulator, I have these different play options. I can just hit play and cycle through the whole thing, or I can advance one step at a time. This is my first record, my next record that will be fed into the system. I get a preview of it there. So I'm going to come into my Geo Event monitor where I watch all of my inputs, outputs, and I can see my count. So when I hit advance by 1, it advanced 1, and 1 was successfully ingested into my system. I want to do 3 at a time. So when I do that, they advance by 3. I can just hit play and let it go automatically. I can let it run on a continuous loop and repeat everything, or I can have it just stop when it hits the end. So I'll reset it, and I'll reset my statistics back to the beginning. Okay, so the next piece is my output connector. The data needs to go somewhere. And so within my outputs, I have update threat cones. The first thing I want to do is convert that CSV into a feature service. So I set up update a feature. This will allow me to draw a feature in my feature service and then have it update periodically. I do have to specify my track ID, my unique identifier field, and in this data is just called track ID. So I have my output configured, and now I can go ahead and build my Geo Event service. So when I build a Geo Event service, I'll name it Threat Assessment, and the name doesn't matter. You can change the name later. It's not going to break anything. I need to have an input. I need to have an output. Those are the prerequisites before I can even hit publish successfully. I have them both. I can hit publish. Right now, there's nothing going to happen or nothing's going to happen, sorry. Data needs to come into the service and then it needs to go out. And here is where I load my processors and my filters. Processors, there's a number of different processors available. Some of these are really familiar to ArcGIS users, people who use ArcMap and Pro and who've taken a GIS course. Buffer Creator, that's very common in GIS. Field Calculator. Some of them are very unique, like Bearing Calculator and Range Fan Calculator. So any type of analytics that need to be done, anything we would normally consider a geoprocessing tool will be brought into this as a processor. So the first thing that I want to add is a field mapper. And anytime I build a sequence of logic within a GeoEvent service, I want to have a field mapper. And I'm going to name it Feature Service Schema. And we've spent a lot of time looking at GeoEvent definitions, and this is where we start to apply the usage of them into our service. The data is coming in under the storm cell predictions schema, but the output is going into the threat cones schema, which matches my output feature service. So I always want to have a field mapper so I can convert the data from one schema to another. So my target fields, this is the landing pad. This is where it needs to go. And then whatever fields from my input, however they need to match up to the output, I can specify. Object ID, shape area, shape length, we can always leave those blank. GeoEvent has no control over those. Those will be handled by the feature service as the features are being edited. So we can just leave those blank. The inputs, if they do match identically to the output, they will auto match up. I can change it. The one field that I need to account for is track ID. There is nothing in my input that's going to fill this attribute field for the time being. So I'll just hit OK for now. And I will use another processor called a field calculator. And I'll name it calc track ID. Grab my field calculator. And this is where I'm going to tell it how to write out my track ID value. Now the field calculator, there's a great documentation page for this, and it's included in my resources slide at the end. I'll do site ID, but it'll take mathematical as well as text strings. So I want it to have the site ID field value with an underscore, and then the storm cell ID value, and then another underscore, and then the minutes out value. And this is an existing field. This gives me a list of every field name in every definition. I want to filter just by my threat cones definition, and I want that to feed into the track ID field. I hit OK, I string them together. So I want to think about how this works logically. The data comes in, the data the data schema will change to what I specified, and then the track ID field will be calculated, and then it will be sent to my feature service. I hit publish, and then now I can start feeding it data. I'll just advance 3 steps at once, and I can see here, just like on the monitor page, 3 went in and 3 went out. So that's a good sign already. And then here's where I would look up my, let's see, I'll just load it in this page, in this browser session. Put in my credentials and don't watch for typos. So here we go. So here's my web map, and I can see my 3 features that I expect to see. And I can see how that track ID is populated with the site ID, the storm cell ID, and the minutes out. So that worked correctly. I have my 45, my 30, and my 15. So that worked exactly how I wanted it to. And now I can come in here. I'll just hit, let's see, let me pull up my dashboard so we can watch that. Okay, and I'm just gonna hit play and let it cycle through. And I wanna make sure that my entire data set, actually, this dashboard is only gonna refresh every 6 seconds. So I'll update that to not be so overzealous. Just send it through every 6 seconds. So about this, the way that works, because I used update a feature, not add a feature. If I did add a feature, it would make a breadcrumb trail of all of these polygons. I did update a feature. So what it'll do, it'll look for that unique identifier, my track ID field, that one that I constructed. As an input record comes in, it'll scan the output data and it'll query it. Is there already a feature that has this value? And if there is, then it will override it. It'll edit that feature. If there's not, then it'll add a new one, which just happened here. This is a different storm area. This has a different track ID, each cell does. And so it added the first one, and then from there on out, it will edit it. And in my dashboard, I have it set to show us the full count of all of the points, which is here, as well as the amount of points that are in the extent of the map. So this number will be changing. And then I have my different storm cells here that are within view, and they'll flicker as I select them. And then my threatened assets, which is 0 for now, because that's the next piece that I need to figure out. So we'll go ahead and we'll pause our activity there. And we know that everything is working so far up till now. And so then the next piece we need to do is we need to identify those threatened assets. Let's get these points to turn red when they intersect with the storm. So a couple ways I can do that. I can consider my geofence. We often think, oh, well, the polygon should be the geofence because that's how it was in the diagram. But that's not always the case. I want to use my critical infrastructure points as my geofence. And the reason for that, there's two of them. One is that's the larger of the data. There's over 5,000 points in that data set. So if it's not the geofence, then I have to ingest it. And that's a lot to ingest, which is often okay, but I need to make sure that I have the capacity to do it. And it's just a much smaller load on the system to ingest the storm cells instead. The other that I want to consider is that it's often better to have the geofence be a static data set. These points aren't really changing very often, and if they are, it's a pretty simple update, and it would be seldom. Whereas the storms are constantly changing, and so it handles a little bit better if I can have the static data as the geofence. So we'll go ahead and get this set up. First of all, I have an output connector already established, and that is my update threatened assets. It's very similar to this, so we don't need to look into that. But we'll go ahead and set up our geofence. So I come into my geofences, and if I have a dynamic data, I can do dynamic data, it's just not as good. But I can set that up here with this synchronization rule, so it'll take changing data and update my geofences. Mine are static, I can just import them directly. And I go to my critical infrastructure feature service. So I just find that service in the portal that it's a part of. I pick the layer. The category field, I could have that populated by a field name. I'm just gonna name them all uniformly though. Critical infrastructure. And I want it to treat my name field as my CID field. That's the unique identifier. So that'll take just a second to load. Each geofence, I'm gonna have over 5,000 geofences. Each one will have a unique name based on that CID field. So here we go, I have 5180 geofences, and each one is named uniquely. They have a common category. And the way you use categories, say I'm using the 50 states as my geofence, my category might be Pacific Northwest region, and then my names would be Washington, Oregon, Idaho. So it's a subclassification of your geofences for when you call on them later. So now let's go back to our Geo Event service, and we will edit it. So I don't want to change anything here, but I want to add on to it. So I want my field calculator to continue to add, but I want it to keep sending to this output. So off of my field calculator, I'm going to add another processor. and I'll name it tag intersecting features. And I'm going to use a processor called GeoTagger. And the GeoTagger takes the name of the geofence. So that's those CID values that we saw. And it will append it into my data. So my geofence, I'll call it by its category, which I need to make sure I spell it correctly. Structure / and it uses regular expression, and this is all in documentation, but I'll put in my wildcard. I want every single geofence in this category. And I want geofences that intersect, we saw these earlier in the slide, intersect the geometry of my data. And I want that that CID, that geofence name, to be added to a new field. And I want that field name to be Geofence ID. And that'll be delimited value. And now I'm changing the schema of my data, remember. I'm adding a new field. And so it doesn't replace my GeoEvent definition, but it adds a new GeoEvent definition. So I need to name that. And I'll name it a long one that I'll recognize. GeoTagger, critical infrastructure, feature, intersection. And I do not want the category name. I just want that number that is the name of each geofence. And I hit OK. And I'll connect my field calculator to my GeoTagger. The next thing I want to do now, say I have a storm that intersects 3 points and they're named 1, 2, and 3. That new field I made, it's going to say 1, 2, 3, which won't be too helpful. I need to separate those out. Instead of being 1 record, it should be 3 records, each with 1 unique value for that. So I'm going to add a new processor, and I will name it split. And I'll use the field splitter. And I'm looking for my field that's called Geofence ID and split where the commas are. And so now my data is changing, and we can see that logic of how it's being changed as it goes through the process. And we always want to have a field mapper every time. So even though it's the same service as before, we're on a different line of logic here. So I'll add a field mapper. Remember that new definition name, that's the current state of our data. And that definition name is not listed here because it hasn't been created yet. I have to hit publish, and I have to send some data through. I sent in some, and now data has interacted with this GeoTagger. Now it should have created my my definition. So when I come into Field Mapper, I have that new definition that I asked for, and I want that to point to my threatened assets feature service, and I'll name this threatened assets schema, and I'll accept a typo and move on. Geofence ID, that's that new field that I just created. That's going to feed into the reference ID value. Reference date, this receive time is just available. I'll take it. When data hits this processor, it'll capture the time in Unix time, and it will stamp it. And then I'll have that track ID, which is my unique value for the threat cone that will feed the threat cone ID. So I have that mapped out. There's one last one that I need. My data up to this point, it has all the values that I want now, but it's the geometry of the threat cone of the storm. I need to have the geometry of the points. So I like the creativity of this. And a lot of using GeoEvent requires some creativity, but and I can't take credit for it. But the way I'm going to convert that geometry is with a field enricher. Field enricher can come from a file or from a feature service. I'm going to call it get threatened asset geometry. And I'm going to pull from my critical infrastructure feature service. That's the one with the 5,000 points. And that's the layer. And the join field will be the CID. And that will match my threatened asset reference ID. Remember my field map, right? Had that value, the CID, the geofence name, which is CID, will feed into the reference ID field. So that's what they're going to join on. And it's going to pull an existing field called geometry that is common between both data sets. and it'll take the geometry of the points and replace the geometry of the polygons. So now that's ready to go. I can add that in, and then I can pull in my output connector and connect my last processor to my output. There's these little tools to line everything up right and make them attractive if you want to, but I'll just accept it for how it is. So now I come through and I hit advance once, and let's just make sure. Yep, 3 went in, 3 went out. And let's see how it shows up on my dashboard. I'm just gonna go ahead and hit play and let it do its thing. So now, again, that should refresh every 6 seconds to where the storms should be moving, and they should be drawing the dots red, like we're seeing. So those dots are being drawn red. They're identified as threatened assets. My dashboard is updating. So it's doing what it's supposed to. Later on, I might want to add a cleanup job, add some more logic to have these points removed so they're not red anymore, but that would be a topic for another day. So now we'll just come back to our presentation. And just to wrap it up, these will all be in the slides. Here's some examples of how we might make dashboards with that kind of data. And then we can take all those all of these different types of resources of real-time data. I'd recommend playing with this tool sometime, but it pulls in data from a lot of different places. We can use GeoEvent, or we can use Living Atlas resources, or static data like population, and all of that can feed into, here I'm looking at within this polygon, what is nearby during some sort of disaster or event, and I can get all of those numbers. And if the data are being created real time and fed real time in real time, then the current numbers will show up in real time in that application. And here's another example of taking real-time data and putting it together into a nice, slick application. Here's that list of resources that I had mentioned. So all of those are hyperlinks that will work in your PDF that you downloaded. And then here are the upcoming events, meetups, webinars. We also have a seminar series in a couple weeks. If you're in the Raleigh or New York areas, please come join us. It's free admission. We give you lunch. It's an all-day activity on the 1st and 3rd. And the sign up is there. So please come join us. We do have some space available. Here's my contact info. If you have any ideas for future meetup topics that you'd like to see, feel free to reach out to me or contact me with any questions you have. And Shannon, back to you.
All right, awesome. Thank you, Matt. So while I see a few of you putting in your questions, we'll give you a few more minutes to add any more that you want. We'll start off with a few that I see already in here, Matt. So the first question is, what are stream services and how are they used with GeoEvent?
Oh yeah, good question. So stream services are one of the output options. So the way that I used a feature service to draw on the map, you can use a stream service instead. Stream services, they're really lightweight and they allow you to draw a lot of data really fast. They are unique to GeoEvent. You publish it from GeoEvent as you're building the output connector. The difference between it and a feature service is that stream service data are not stored on premise. They're just stored in the browser session. So you see all the points show up on the map. As soon as you close out of the application, the points are gone. So if you don't need to save the data, but you just want to be able to see a lot of data at once, then a stream service is useful. But if you need to store the data, then it's not the right choice.
All right, awesome. And another question, how much data can GeoEvent handle at a time?
So it will, of course, depend on the machine's power and the complexity of the data. The most recent certified benchmark that I've heard, it was 10,000 events per second, I believe. So 10,000 events ingested and pushed out to the Spatialtemporal big data store. And that's using some really beefy servers with minimal attributes in the data. The more complex the data, the more that it gets processed through the Geo Event Server, through the Geo Event Service. All of those will be factors, but so that's the high end on the simplest case scenario.
Perfect.
10,000.
All right, unless no one has any more questions, thank you again, Matt. As he said, you can find him there at his email, and he'll be back in November for our next meetup on ArcGIS Hub. Thank you, everyone, for joining, and thank you, Matt.
Thank you.